Thank you very much, everyone. The purpose of this talk is to have a conversation between me and my colleague, which is working as an AI engineer in Cytomate, to see that how Yara rules can be generated through LLM. So that's our main focus, as well as we will be comparing the output with Llama, with ChatGPT, and with DeepSeek in terms of their reasoning process as well. Actually. My name is Masoom Alam, and I'm the Chief Technology Officer of Cytomate, whereas Miss Tehniyat Saif is working with us as an AI engineer. Uh, the outline of this presentation is, first of all, we will see the process of manually crafting the Yara rules, like what is the process which is being followed, and then how the Yara rules are generated through LLMs. And we will actually go in depth for understanding the workflow of LLMs to generate Yara rules, and we will do comparison. Also, we have some good examples as well as in practical for understanding like what is actually going on. So first of all, the objectives of this talk are that we will be talking about the reasoning abilities, which is going to be a comparison between ChatGPT, DeepSeek, Llama, and Gemini. And we will see that if they generate rules, okay, how much their reasoning abilities are powerful. And we will also do some performance evaluation as well. And then we will provide some actionable insights like for cybersecurity professionals, which are using LLMs for similar purposes, like for generation of Yara rules. So what is actually the manual and LLM generated Yara rules process? Yara rules actually work in malware detection. How they works actually that you have some patterns which you include in a script, and that script actually includes strings. That script also include conditions as well. Okay, and then you search for them while scanning, and also you can integrate with other security softwares as well, so that Yara rules can be triggered through those softwares. And this whole activity is actually part of response and mitigation. So it's more on the incident response, actually, those facilities. What is the process of manually writing Yara rules? First of all, we have to collect the sample, we do the static analysis, and then we do the dynamic analysis for that. So like a reverse engineer, they will collect the sample, perform the static analysis, and then it will perform the dynamic analysis to do that, basically. Okay, so this is the whole process of creating a Yara rule for a reverse engineer. Now, the Yara rules also contains some unique signatures as well. Like, for example, you can have some encryption keys or even behavioral markers as well. And you focus on non-generic patterns, for example, custom C2 URLs, or you can have even IP addresses as well. So this is actually the way forward that you want to do for the creation of the Yara rule. So you have metadata, you have strings, and you have conditions actually that you can include. And one Yara rule actually can match with multiple malwares as well, or a class of malwares as well. So this is actually the whole mechanism. This is an example Yara rule. So you can see, first of all, there is a meta information, like who has created this rule, what is the date, what is its version, for example, or what is the MD5 for this thing. Then we have some strings. These are the meaningful strings that should be present in a file to be matched with this Yara rule. And then we have few conditions which are matched, like, for example, the unit 16.0 should be this specific string actually. So this is the part of the actual thing. Now, string specification under the Yara rules are like this. You can see that suspicious strings are mentioned. Okay, you can have some IP addressing as well, like based on the threat intelligence, you can have them, and you can have some generic rules as well. So that's all actually that's part of, like, you want to describe the malware in the best of your capabilities. So that, I mean, these Yara rules can be used by the organizations to search for specific IOCs in their environment. Now, what's the difference between Yara rules and traditional antiviruses? Yara rules have different benefits because they are based on the pattern matching. They have the flexibility, they can be changed and updated as well. Okay, and there are custom rules. While traditional antiviruses, actually, because they are only signature based and they do real-time scanning, so they have a limitation that they struggle with AI-driven threats. Okay, and they have higher false positive because they are focused more on the signatures. Now we will actually, now that we have a small refresher course on the Yara rules and how they are being built, now we will focus more on the LLMs, that how LLMs are used to generate them. So first of all, what's the process for ChatGPT, for example, to create Yara rules? What we do is that we have the file metadata, unique strings, priority, and non-generic patterns actually. But one thing which is very important to mention here, that because of the limitation of censorship, okay, and also because of the size limitation as well, we did not give any binary file to ChatGPT. Okay, so this was only that we gave it a link of a hybrid website, and we actually asked ChatGPT to go there and do the analysis. Now, ChatGPT did some processing as well, okay, and it actually converted the prompt into a set of tokens actually. And also we gave the hybrid analysis link as well. We wanted to ask the ChatGPT to process that, and ChatGPT was performing that. But luckily, because when we enabled the reasoning of ChatGPT, we came to know that ChatGPT was not going on the link, okay, so it was not processing any information. That's why then we gave pre-process information to ChatGPT so that it can actually generate the Yara rule for us. On the other hand, DeepSeek is having much more credibility, because if you give the link to DeepSeek, it actually goes on that link and also process that information which is present on the link as well. And this is evident from the reasoning capability of the DeepSeek. Now we will have a comparison of generated Yara rules through multiple parameters. Okay, first of all, the comparison is being made on three aspects. First of all, string extraction, like how these models are extracting the strings which are really relevant, and there are less false positives. Okay. The second one is actually the rule structure and complexity. So how much sophisticated it is to match the string, the exact string actually, and reasoning quality as well. So like how much reasoning quality is there to explain the logic behind creating that Yara rule. Now, identifying, first of all, I mean, we actually check with Nextron, which is a company for compromise assessment, and we look at it like how they extract the string. And please keep in mind that this is the manual process actually. Okay, so you can see that it is really, really up to the mark, because the human intelligence is included, and you can have like very actual strings or the description of the malware through reverse engineering. But this is manual actually, so human is doing. ChatGPT string extraction, on the other hand, is actually very weak. You can see, and no unique or robust strings that do exist any Yara rules available online. So that's why like ChatGPT was not able to comprehend the information. One reason that I already gave, that it is not going and extracting anything on a given link actually, and because of the limitations, we were not able to give a binary to ChatGPT for analysis. So string extraction, on the one hand side, actually it identifies variety of strings, misses more complex behavior. So DeepSeek, on the other hand, have a combination of unique and general strings actually. So it is able to identify unique strings, but it has some issues in the general strings as well. Okay, for the detection of the malware samples. And here I'll ask my colleague as well, Miss Tehniyat, also to jump in, and also if she wants to add something, that will be really helpful.
Okay, thank you so much, sir, for letting me in this call. I have some information regarding DeepSeek as compared to ChatGPT, as its strings are more specific to that particular malware or content that we provide to the hybrid analysis link of malware sample or some extracted content as an input file. So basically, it have some unique and robust kind of strings that are not included by ChatGPT while crafting the Yara rule against that particular malware. Also, we try to generate Yara rules from some other platforms like Llama platform. It do not have any specific unique or robust or any kind of textual ASCII or white strings, like we have some strings malicious or that kind of content in DeepSeek R1 and ChatGPT based content. But here we can see just an example of opcodes against that similar malware with say similar query. So it do not have any unique or robust string that uniquely identify that particular malware instead of some generic content. Now we will move towards Gemini. This platform also utilize thinking and reasoning ability like DeepSeek R1, but it is not able to give us some unique or some content that actually set as per the standard of Yara rule. Like we have some strings content, meta portion, and condition information obviously here, but we cannot see some hexadecimal string or codes or generic or any kind of textual content like URLs,
So,
IPs.
ma'am, what your point is that ChatGPT, because it was not going on the link, DeepSeek was having a mixed analysis, then the Llama specific model actually, and then Gemini. So, which is the winner actually, in your opinion?
So, in my opinion, as DeepSeek is also utilizing reasoning and thinking ability on our given query, so its response is far
Fairly
better than
better.
ChatGPT
Far
based.
better. Okay. Okay. So, this is one of your conclusion actually. Okay. Okay. What
Yes.
about the rule complexity? If we see the Nextron rules, so Nextron rules, of course, I mean, they are created by humans, right? So it means that they have more sophistication. Why? Because they are created by humans, right? And because of their experience. But what do you think about the models actually? What is what is your opinion about the models actually?
So actually, next-on-based Yara rule is able to uniquely identify its own sample, like the original sample against which we try to elaborate this whole Yara rule generation process through LLM. It is able to identify that particular sample and as well as its variant, like we try to pass WannaCry sample, WannaCry related information to other LLMs. And here we can see that it is able to identify WannaCry sample and all other variants available on my system. Also, as it has some generic but malicious content in it that is unique, that is able to uniquely identify its own sample. Like we can see, we also try to validate other examples based Yara rule. Actually, we try to validate ChatGPT based generated Yara rule as well, as we already have seen that it has some generic content, but generic and malicious content, but do not include any unique or malware specific string or other than signature and all. So that's why it is able to it is not able to uniquely identify or detect its own binary and its variant. It do match with all kind of variants of malwares available on my system. Here we can see that it is not able to identify any kind of particular WannaCry sample. Like you can see with .exe extension, there is rat sample or virus or Trojan. There is nothing belong to ransomware or WannaCry sample. So it is not able to uniquely identify any single WannaCry sample here, not even its own sample against which that particular Yara rule was crafted through ChatGPT. As we already discussed, that DeepSeek R1 is able to identify some unique strings other than generic and malicious content. So it definitely able to identify its own WannaCry sample, like the sample against which we try to generate Yara rule. And also it is as per the standard or standard of Nextron based Yara rule. Okay, here we can see that like we already have seen this kind of information in Nextron based content. Like here we can see that it is able to identify some WannaCry samples, included its own. So it is not able to identify its own type of its own malware or sample. Actually, it do
So what you
match
are
with
saying
all
that
type of.
the rule generated by Gemini was really useless, right? This is what you
Yes,
meant,
sir.
right?
As we already discussed about its detail. Yes, sir. It is not
Okay,
as per the standard of Yara rule as well.
okay, okay. Can we now
Okay.
compare the reasoning process as well? Describing the reasoning process as well. So ChatGPT is using SFT model, right? And it is also taking into
Yes,
account
sir.
reinforcement learning from human feedback as well. Okay, so this is how it is being generated. But actually, my question is that why even having a reasoning process? Why ChatGPT was not very successful in Yara rule generation? What is your opinion about that?
So basically, there is no reasoning process available on a free version of ChatGPT like 4.0 or ChatGPT Turbo platform. It works on the basis of SFT model, that's like supervised fine tuning model that works on the basis of reinforcement learning or pre-trained content. It do that.
Okay,
So
okay. So
basically,
it does not have any pre-trained, even on the pre-trained model as well. But for example, if we see the SFT, which is supervised fine-tuning, right, and we compare it with, for example, DeepSeek. So why you think that DeepSeek reasoning is more attractive for us? What's the reason for that?
okay. So basically, DeepSeek reasoning is more attractive for us as because it works on some rules. Like when we try to generate some query, when we try to generate some content from DeepSeek based model, it do try to understand our query first. It do try to understand the output relevant to that particular query based on the rules and prompt. Like you can say here an example. Where I try to highlight some point, like it works on some rules, like which portion of our query is belong to the thinking purpose and how we will elaborate our thinking process answer in answering the query of that particular user.
But is there
Like
is
we
any
try.
particular algorithm that is being used by DeepSeek for the reasoning? So, like for example, the DeepSeek R10, which like learns from itself actually, right? So, what's the mechanism? And this is actually a snapshot audience from the DeepSeek R1 reasoning research paper. Okay, so this is how like this is a
Yes, sir.
kind of re-evaluation again and again and again. So it learns from itself as well and kind of like reasoning to itself. So what do you think about that? Do you have anything in mind for Yara rules actually of this process?
Yes, sir, I have some information like DeepSeek R1 is not only the model generated by DeepSeek platform. It has some other variants as well. And one of its variant is DeepSeek R10, where they try to generate some information regarding the input query. And through that, they are able to identify that it has some limitations, like it tried to generate some output against our input query. But that output is not as per the standard of our requirements. So it tried to re-evaluate its query, its output generated content, our reasoning, our thinking, so that it do match our requirement and language and abilities, each and everything. And as per the standard of Yara rule, in the context of our query, like we try to generate Yara rules from large language models. So R1 is better. R1 is better in reasoning, as we cannot see any kind of deep analysis or thinking from ChatGPT platform, which we can see here in DeepSeek R1, as it try to understand the input, it try to understand what kind of output should be there in the generated Yara rule, like which string is unique, which string is general, and which string need to be append to that particular Yara rule, instead of randomly shuffling or appending any kind of string or content in that output.
Okay.
Okay,
So you
so
want to
here
say
we,
something about this thing, for example, the DeepSeek with respect to Yara rule
yes,
based reasoning? Yeah.
here we can see some points on which basis that DeepSeek actually gave us the Yara rule. So basically, it tried to understand first the hash, common suspicious strings, and some indicators and behaviors from the link or the report of hybrid analysis that we provide as the input query that to DeepSeek R1, similar to ChatGPT. But ChatGPT do not perform any analysis. It do not approach that particular link, as it just gave me the response that we cannot access that particular link. But DeepSeek R1 do approach that particular link and gather the specific information, like it try to understand the content available in that hybrid analysis report or any
Yeah.
sandbox report as well.
Yeah, and you have given like the comparison as well of the reasoning and also the OpenAI models and the deep.
Here we have a comparison of reasoning module of ChatGPT as well. Like ChatGPT do have a reasoning model, but that is not available freely. That model is known as OPT OpenAI O1 mini variant, and the other name mentioned here as well.
Yeah,
And
yeah,
in that comparison, we try to compare DeepSeek R1 variant. So
yeah,
basically,
yeah. Which
here
is
we
like
can
way
see
forward,
that
and also the overall rating. If you can see that DeepSeek R10 is having much more information, and it's actually performing very well in terms of reasoning, right? You
platform
have a
as well.
very interesting diagram, and I want to understand that how this adversarial testing. So, for example, if tomorrow some hackers or state level actors, they also have access, and of course they have access to open source DeepSeek models and these LLM models as well. So, how can they actually generate a new malware out of it? How can they do it, by the way? So
Okay.
you will
So
provide, I mean, is
basically,
it,
sir,
so the diagram is saying, sorry, I'm cutting you. So diagram is saying that you have a Yara rule and you have a malware, right? And you give it to LLM and then you can generate a new malware, right? Which will be non-evadable, like it will be not catchable by any security control. Is this what the whole meaning is?
yes, sir, as we try to generate some ethical content from LLM, so we also have try to grab some information about hacker point of view. Like if an attacker tries to grab some
So dark side
try
of
to
LLM
generate
actually needs
Yara
to
rule.
be discussed as well, right? Dark side of there as well.
Yes, sir.
So okay, that's that's
Yes, sir.
that's very interesting actually. And also one more aspect that I want to give that there are some blogs available actually, which we'll actually include in the description of this video, where you can go and see that how AI actually can generate a polymorphic variant of a malware as well. Okay, so this is actually now can because it can evade security products and complicate mitigation efforts. So this is also something that we need to understand actually. So this is here how we are showing that how, for example, to generate a malware file and how actually to have an execution of that. Okay, and possible effects are that you can have a key logging or privilege escalation or backdoor access malwares generated through the AI actually. What's your point of view on these slides?
So basically, that adversarial testing is based on polymorphic malwares, like those malwares that do not have specific or signature, like static signature. It definitely or gradually changes its signature and content. That's why it is not able to detect by, it is not detected by EDR, any kind of antivirus or these type of platforms. So basically, we try to generate similar kind of malware and content that we inject in any executable file, and then we will see that whether this particular file is not detected by EDR or any
So you are
system.
actually giving us the process of having a malware which is generated by the LLMs, and actually they are evasive actually, right? So you give them the Yara rules as well, so they create a malware out of it, which is non-invasive, right? And then it is evasive in the sense that it will bypass the security control. Is this what the message is, right?
Yes, sir. And also, I have another point to mention here that even though we try to generate polymorphic samples, as we know, these are not detected by any kind of EDR or any kind of antivirus or detection platform, but also we try to generate Yara rule against those polymorphic malwares or samples or injection content so that we can have some idea that whether Yara rules are able to identify those samples or not. And
Yeah.
ChatGPT and DeepSeek R1 do give us some samples, Yara rules, and some information through which we can say that we are able to identify that particular injected malware or polymorphic type of malware
Yeah.
that do change its signature.
Thank you so much, Tehniyat. It was really nice talking to you, and this was really, really helpful in understanding the state of the art. And of course, we are doing research, and we will be actually sharing our results with the community as well. Okay, so thank you to all actually who are listening this talk, and a detailed description will be added as well as all the links and every malwares that we tested that will be included as well. Thank you so much, Tehniyat. Thank you for your
Thank you so much, sir.
presence and actually helping me in organizing all this material. Thank you.